that came out of that. We're limited here primarily by biological reality and our imagination. We now have techniques, because of these rapid methods of synthesis, to do what we're calling combinatorial genomics. We have the ability now to build a large robot that can make 1 million chromosomes a day. When you think of processing these 20 million different genes, or trying to optimize processes to produce octane or to produce pharmaceuticals, new vaccines, we can change just with a small team, do more molecular biology than the last 20 years of all science. And it's just standard selection. We can select for viability, chemical or fuel production, vaccine production, et cetera. This is a screen snapshot of some true design software that we're working on to actually be able to sit down and design species in the computer. We don't know necessarily what they look like. We know exactly what their genetic code looks like. We're focusing on now a 4th generation fuels. You've seen recently corn to ethanol is just a bad experiment. We have 2nd and 3rd generation fuels that will be coming out relatively soon that are sugar to much higher value fuels like octane or different types of butanol. But the only way we think that biology can have a major impact without further increasing the cost of food and limiting its availability is if we start with CO2 as its feedstock. And so we're working with designing cells to go down this road, and we think we'll have the first 4th generation fuels in about 18 months. Sunlight and CO2 is one method. But in our discovery around the world, we have all kinds of other methods. This is an organism we described in 1996. It lives in the deep ocean, about 1.5 miles deep, almost at boiling water temperatures. It takes CO2 to methane using molecular hydrogen as its energy source. We're looking to see if we can take captured CO2, which can easily be piped to sites, convert that CO2 back into fuel to drive this process. So in a short period of time, we think that we might be able to increase what the basic question is of what is life. We're truly, have modest goals of replacing the whole petrochemical industry. If you can't do that at TED, where can you? Become a major source of energy, but also we're now